Hey there, universe nerds! Right now, as you're listening, trillions of tiny particles are streaming through your body. They're called neutrinos, and they're so elusive that you don't feel a thing. Neutrinos are sometimes called ghost particles because they almost never interact with matter. They fly through planets, stars, and even lead walls as if they weren't there. Yet despite their invisibility, they're one of the most important keys to understanding the universe. Today, let's explore what neutrinos are, where they come from, and why scientists are obsessed with catching these ghosts of the cosmos. Neutrinos were first proposed in 1930 by Wolfgang Pauli to solve a mystery in radioactive decay. Something seemed to be missing from the energy balance when certain particles decayed. To fix the math, Pauli suggested a new, invisible particle carrying away the missing energy. For years, neutrinos were just a theory. It wasn't until 1956 that they were finally detected, confirming Pauli's bold idea. The ghost was real. So, what exactly is a neutrino? It's a fundamental particle, part of the standard model of physics. Neutrinos have no electric charge, and their mass is tiny, so tiny that for decades, scientists thought they might be massless. They interact only via the weak nuclear force, which makes them incredibly hard to detect. To catch even a few, scientists build giant underground detectors filled with thousands of tons of water or ice, waiting for the rare moment when a neutrino collides with an atom. Neutrinos come in three flavors: electron, muon, and tau neutrinos. Even stranger, they can oscillate, changing from one type to another as they travel through space. This discovery, made in the late 20th century, proved that neutrinos must have mass, though incredibly small. That was groundbreaking. It showed that the standard model wasn't complete, and that neutrinos might hint at new physics beyond what we know. Where do neutrinos come from? They're everywhere. The sun produces a constant stream of them through nuclear fusion, sending billions through every square centimeter of Earth each second. Supernovae release a flood of neutrinos, carrying away most of the energy from the collapsing star. Nuclear reactors, cosmic rays, and even radioactive decay in Earth's crust all generate neutrinos. They're one of the most abundant particles in the universe, even though we rarely notice them. Detecting neutrinos isn't just about curiosity, it's powerful science. By studying solar neutrinos, scientists confirmed how the sun shines. By catching neutrinos from supernova 1987, astronomers learned about the inner workings of exploding stars. Today, detectors like Super Kamiokande in Japan and IceCube in Antarctica are capturing neutrinos from across the cosmos, even from distant galaxies. Neutrinos are messengers, carrying information from places light can't escape. One of the most exciting frontiers is using neutrinos to explore the early universe. Right after the Big Bang, neutrinos streamed freely, forming a cosmic neutrino background. Detecting it directly would give us a glimpse into the first seconds of time, even earlier than the cosmic microwave background. It hasn't been measured yet, but experiments are pushing the limits to find it. If we succeed, it would open a new window on the birth of the cosmos. Neutrinos might also connect to dark matter. Some theories suggest new kinds of sterile neutrinos could make up dark matter. If that's true, neutrinos could explain one of the biggest mysteries in physics. Even without that, studying how neutrinos behave could lead to discoveries that go beyond the standard model, maybe even hints at a deeper theory of everything. What's humbling is that neutrinos remind us how much of the universe is hidden. We live surrounded by ghostly rivers of particles, silent and invisible, yet essential to the story of stars, galaxies, and life itself. The fact that we can even detect them at all is a triumph of human ingenuity, building massive detectors to catch whispers from the cosmos.
So, what are neutrinos? They're ghost particles that barely interact, passing through you by the trillions every second. They come from the sun, supernovae, reactors, and even the Big Bang. They may hold clues to dark matter, to new physics, and to the universe's earliest moments. Next time you step outside, remember, you're bathed in neutrinos, cosmic ghosts reminding us that the universe is richer and stranger than we can see.